Hello, my dear students. My name is Dr. Amit Tomar. I am a senior assistant professor in Department of Physics and Astronomical Sciences, Central University of Jammu campus. Today, I am here to present a very important video lecture regarding your CUET entrance examination in physics. So, the title of my today video lecture is Characteristics of Electromagnetic Waves. Let's start. So, here is the first PPT. First, I read individual points one by one, and then we explain by taking individual points so that you may understand in very better way. So, the first point regarding the introduction of electromagnetic wave is that the electromagnetic wave are the waves that consist of oscillating electric and magnetic fields which are perpendicular to each other, and these two fields are perpendicular to the direction of propagation of the wave. What does it mean? It means that when the wave propagates in x direction, then magnetic field may be in y direction and z direction, and the electric field is the perpendicular to both magnetic field and electric field. In some other words, these are at the 90-degree angle between each other, so that the wave form the electromagnetic wave. In some other simple words, that if a wave originates by the charged particle and the wave propagates in some direction, let's say, for example, maybe wave propagate in a x direction, it may be y direction or it may be the z direction. But for example, let us say it is in the x direction, so magnetic field must be in the y direction or z direction, and the vice versa. And the magnetic and the electric field is maybe in the x and the sorry, maybe in the y and the z direction. So keep that in mind. These three parameters: the direction of propagation, the direction of the electric field, and the direction of the magnetic field. These three are perpendicular to each other. This is the basic condition for the wave to have the electromagnetic property in in their propagation. The second thing is that the nature. Basically, some wave require medium to propagate, just like a sound wave. So basically, the electromagnetic wave required no medium to propagate. The electromagnetic wave easily move in vacuum. As we all know, the basic example of electromagnetic wave are the sun rays, which comes from the space, and in space we have a vacuum. So electromagnetic wave doesn't require any medium to propagate. This doesn't mean that they don't propagate inside the medium. They do so. So they move inside the medium or without medium. Electromagnetic wave are transverse in nature. Basically, transverse in nature is the basic property regarding electromagnetic wave. What was that? What is the transverse nature reflects regarding the wave? It reflects that the plane of vibration is perpendicular to the plane of the propagation of the electromagnetic wave. In some other word, the plane in which the electric field vibrates must be the perpendicular to the direction of the propagation of the wave. Or in simpler way, the direction of the propagation of the wave is perpendicular to the direction of the electric field. In other simple words, because it is the electric field which is responsible all the optical property of electromagnetic wave. So electric field is the uh, quantity which is responsible to generate the optical property regarding wave natures. So electric field must be the perpendicular to the direction of the propagation. This is the basic requirement regarding transverse nature of the electromagnetic wave. So let's move further. Here is the speed in vacuum. So keep that in mind. In free space, the electromagnetic wave has a speed which is equal to the 3 into 10 raised to power 8 meter per second, and it is nominated as the speed of light. It is the maximum speed achieved by the any particle in the nature. No one particle can achieve the speed which is greater than the speed of light, or we may say that it is the limit, it is the maximum limit of the speed which is achieved by the any material particle. And if any one particle or some you may say the some material, if they achieve the velocity greater than speed of light, then they are not in the category of the materials. So keep that in mind. It is the maximum speed in vacuum, in free space, the speed which is achieved by the any particle. So it is the limit which we have on the speed of any particle achieved by the achieved by any particle in the nature in free space. So as we all know, the speed decreases as we comes inside the material medium according to the refractive index of that particular medium. So that is another topic. So let's move on the our basic topic, which is the electromagnetic wave and its characteristics properties. So now the next point comes, E and B are in phase and mutually perpendicular, and their amplitude are related by the relation which is given by the equation E equal to BC. Here E is the electric field and B is the magnetic field. And as you see, K by omega is the relation which is represented by the inverse of the speed of light. So basically the basic relation is E equal to BC. It is a relation which is in between the real magnitude of electric and magnetic field in free space. Keep that in mind. We are now discussing the electromagnetic wave in free space. Electromagnetic wave in conductor is another very detailed topic. So we are just giving you the idea in free space what is the relationship between electric field and magnetic field. If we are going in the conductor or other material medium, then this relationships may change accordingly. So here is some example of electromagnetic wave, light waves, radio waves, X-rays, micro. These basically are the different components of the sun rays spectrum. So, or we have lots of very high range electromagnetic field according to their frequency, according to their wavelength. We may nominate the particular name so that it easy to recognize between the very large number of electromagnetic wave. So let's move to the next PPT. So here is some basic point regarding the formation of electromagnetic wave. So first I read the points individually and then we explain in the very detailed manner so that you may understand the physics behind the formation of the electromagnetic waves. So here is the first point. Electromagnetic waves are generated when charged particles accelerate, such as during oscillatory motion. This acceleration creates changing electric and magnetic field that propagate through space. So, what does it mean? It is a very important point regarding the formation or from where we have to start regarding electromagnetic wave. This is the point which gives us the all information regarding the origin from where the electromagnetic waves are start. Here we have read some points regarding acceleratory charge particle, oscillating electric field. What does it mean? It means that when the charge particles moves in a acceleratory motion, that is, it has an acceleration. It is not time independent. It is time dependent motion. So these charge particles create the electric field, and these charge particles also create the magnetic field because time time dependent electric field create the magnetic field. And this basic combination of electric and magnetic field which is generated by the acceleratory charge, or which is generated by the uh, charge which is a time dependent motion. So these electric field and magnetic field are also time dependent, so that we may nominate them as a oscillating electric and oscillating magnetic field. So basically, these oscillating and electric and magnetic field create the electromagnetic wave. So basic requirement for the production of electromagnetic wave is that the charge which is at the rest may produce electric field, may produce magnetic field, but they don't produce the electromagnetic wave. only the charge which is the oscillating charge, or we may say that the accelerating motion, or the charge which is moved in a circle with uniform speed. This is another example which I will explain in some next few minutes. So now come to the original point. The oscillating electric and magnetic field are responsible to generate the electromagnetic waves, or in other words, the charge which has the accelerating motion, the charge which moves with the velocity, which is a changes with time. The velocity, the speed should not be uniform. The uniform speed movement of charge produce the electric field, which is time independent, produce the uniform current, which is the cause of the magnetic field, which is also time independent. But we have to make our electric and magnetic field should be time dependent, should be oscillatory, so that they may produce the electromagnetic wave. So these are the some basic points regarding the formation of electromagnetic wave. I repeat once again because it is very important. The time dependent, the oscillatory electric and magnetic field, the charge which is in motion and having the acceleration, having their motion with time dependent properties, are responsible to produce the electromagnetic wave in nature. So the charge which is at rest or which is in the uniform motion doesn't has the capacity to produce the electromagnetic wave. Here is some very important example regarding your competition examination. Let us suppose some charge particle, maybe electron, maybe proton, or some other charge particle, move in a circle with a uniform speed. Is it possible to produce the electromagnetic waves? First of all, the sudden answer is that the speed is uniform, so uh, these charges are not able to produce the electromagnetic wave. But the answer is wrong. The correct answer is the charge particle which has the uniform speed are in the capacity to produce the electromagnetic wave. The answer is that one correct. And the reason why is it so? Is it so when the charge move in a circle with the uniform velo with the uniform speed, then at the every point in the circle, the direction of the speed is changes. It means that the velocity changes and it generates the acceleration. So the charge particle moving in the circle with uniform speed are also generate the electromagnetic wave. But if this charge particle moves with the uniform speed in a straight line, then it doesn't have the capacity to produce the electromagnetic wave. So these 2 points are the very important points, and I think I have to explain in some better way. Let us say the charge particle moving with the uniform speed in a straight line in one dimension motion. So this charge particle doesn't have the acceleration. The electric field produced by the this charge particle is time independent, that is static electric field. And so for the generation of electromagnetic wave, we have to generate the time dependent oscillating electric field. So the story is finished here. The charge particle which is move with a uniform speed in a x direction doesn't have the capacity to produce an electromagnetic wave. But if this charge particle moves in a circle with uniform speed, then this charged particle have the capacity to produce the electromagnetic wave because it is in the accelerating motion, and the electric field produced by the this charged particle is oscillating and time dependent electric field, and the magnetic field produced by the this charged particle is also time dependent. So oscillatory electric and magnetic field are basic requirement for the generation of electromagnetic wave. I think I have spent lots of time in this point. Let's move further. These fields are perpendicular and self-sustaining, with the changing electric field inducing a magnetic field and vice versa, as described by the Maxwell equation. Here is a just a Maxwell equation, basically, as we all know, very useful regarding the speed of electromagnetic wave. The basic significance, the basic outcome of the Maxwell equation is the speed of light. It gives the information about the speed of light. So basically, this point tells us that the electric field, the magnetic field, and the direction of propagation are all mutually perpendicular to each other. So here is some other key points we have discussed already. Accelerating charge, example electrons, maybe proton, and maybe other charged particle, also able to produce the electromagnetic wave. Under condition, they are in the position to produce the oscillating electric and magnetic field. Basically, a time varying electric field produce a magnetic field, and a time varying magnetic field generate an electric field. This is already as in the form of the Faraday law, that the changing electric field uh, and changing magnetic field are able to produce each other. Basically, wave propagation, the interaction between these fields forms a self-propagating wave moving through space without need for a medium. So we have already discussed that electromagnetic wave doesn't require any medium to propagate, and the basic example is the sunlight, which comes from the space, and we feel the sensation when these sunlight touches our skin, so that we may say that doesn't require any medium electromagnetic wave to propagate. So now move to the next PPT. So this is very important PPT regarding the generation of electromagnetic wave by the oscillating or vibrating charge particle, and what is the shape of the electric and magnetic field, and how the wave propagate, we have discussed in this PPT. So just you see in the picture, there is a plus charge. This charge may be a negative charge. So basically a charge particle, whether it is an electron or whether it is a proton, it doesn't matter. So vibrating charge particle generates vibrating electric and magnetic field, and these vibrating field make up a electromagnetic wave. So basically the direction shows by the green arrow for the magnetic field, and the red arrow for the electric field, and the black arrow for the direction of propagation. So it is just a basic example regarding your some better view how the wave propagates and it move in the x direction. Let us say the direction may be x, y, z, no, not fixed by not fixed by anyone. But the point is that the direction of the propagation, the direction of the electric field, and direction of magnetic field, all three are mutually perpendicular to each other. If any two are in the same direction, then the condition of transverse wave is not fulfilled, and the electromagnetic wave is not generated by that particular charge particle. So here we have seen some basic colorful pictures regarding the direction of the electric field, direction of the magnetic field, and direction of the propagation. So now let's move further. So basically, now I want you to understand the basic property of electromagnetic wave by a solid example, so that you understand some better way. So basically, here is a picture in which the charged particles move in the z direction. So it is the direction of the propagation of the charged particle, or it is also the direction of the propagation of the electromagnetic wave. So we may say that in a particular example, the wave propagates in the z direction. The electric field, which is also the field of the vibration of the electromagnetic wave, is point out in the x direction, and the magnetic field shown by the blue line is a vibration in the y direction. So again, I want to repeat this point. The wave propagate in a z direction. The electric field vibrates in a x direction. The magnetic field vibrates in a y direction. Now let's move further. Or here is the speed of light with which electromagnetic wave propagates in space or in free space. In free space, electromagnetic wave always propagate with the speed of light, but in some material medium, the speed is decreases accordingly as per the refractive index of that particular medium. It is the maximum speed by which the particle or electromagnetic wave can propagate, can achieve in free space. No particle available which may achieve the speed of light in greater than the speed of light, And if it achieved, then it cannot be considered in the category of the particle. Keep that in mind. So here is the next part of the example. As we say, we have some basic equation regarding electric field and magnetic field. So I will explain one by one. So as first equation, I just read out E equal to basically E equal to E naught. E naught is the real amplitude of the electric field, and here is some exponentially nomination regarding the electric field, and the electric field is in the x direction as we have already explained by the figure. Again, I just show you the PPT. Sorry, this one, electric field in the x direction and magnetic field in the y direction. Now comes on the original PPT. Here is the first equation regarding the electric field and the second equation regarding the magnetic field in the y direction. These are the equations which just represent the electric field of the generation of the electromagnetic wave in free space. In material, this form may change. So this example for the free space generation of electromagnetic wave by the charge particle. So here we have the B equal to E naught by C or B equal to B naught e raised to power kz minus omega t. Here z is the direction of the moving of the charge particle or moving of the electromagnetic wave or the propagation of the wave. So we have the electric field in x direction, we have the electric field in the y, magnetic field in the y direction, and we have a propagation wave in the z direction. Now taking some real parts, so we have the another form the equation in the term of the cos, and here we have C E equal to E naught cos. In the inside the bracket we have kz minus omega t plus delta. Here delta is a phase difference. So as we know, in a case of a free space, the electric field and magnetic field are in the same phase. But keep that in mind, this same phase relationship only for the free space. In case of conductor, we have a phase difference between electric field and magnetic field of the order of 45 degree. So here in free space, the delta is 0, but in case of conductor, they do possess phase difference between electric field and magnetic field. I want to explain this point again. In case of free space, electric field and magnetic field are perpendicular to each other, but they are in the same phase. They have a zero phase difference between each other. But in a case of material medium, in case of conductor, we have a phase difference of pi by 4 or 45 degree between magnetic field and electric field. Keep that in mind. In conductor or some other material medium, they are not in the same phase. But in free space, they are in the same phase. This condition is uniform that electric field, magnetic field and direction of propagation is always perpendicular to each other, whether they are in free space or they are in the material medium. So I think this point is clear here. Now move to the original equation. So here is some general equation. E equal to E naught e raised to the power k dot r minus omega t. The unit vector n shows the direction of the vibration of electric field, and the direction of the vibration of the electric field or direction of the vibration is perpendicular to the direction of the propagation. As you see in the last equation, n unit vector is scalar product, that is the dot product, with the k unit vector equal to 0. It represents the transverse condition of the electric field, or in some other word, the direction of the polarization, the direction of the electric field. The direction of the plane of vibration is perpendicular to the direction of the propagation of electromagnetic wave. And we know our direction of the polarization or direction of the electric field is in the x direction. And if we scalar product of I unit vector dot k unit vector is equal to 0, as we know these three vectors are perpendicular to each other, and by simple mathematics of scalar product, we comes to the answer which is equal to 0. So if this condition fulfill, if this condition satisfy, what was that? the direction of the polarization, the direction of the electric field, the direction of the propagation is perpendicular to each other, and this is the basic condition of the wave to have the transverse in nature. So we conclude that the electromagnetic wave is transverse in nature. So keep that in mind. It is a very important property, and in every computation, so many questions continuously asking regarding the transverse nature of the electromagnetic wave. Now move to the next PPT. So here is some important property regarding electromagnetic wave. First of all, I just read one by one, then explain in a some detailed manner. So electromagnetic wave exhibit unique property that distinguish them from other type of waves. These waves do not require a medium for propagation and can travel through a vacuum. And we have discussed this point already in a very detailed way. They are transverse. These are the transverse wave, and the oscillatory nature of electric and magnetic field we have already discussed. We have discussed so many points regarding the propagation of electromagnetic wave. Some again key points regarding the transverse nature. The electric field, the magnetic field oscillate perpendicular to each other and the direction of the propagation. Again, we have the speed of light of the electromagnetic wave. Basically, this is the uh, speed which the any particle achieve in the free space. So it is nominated by the c, and its value is 3 into 10 raised to the power 8 meter per second. So it is the limiting speed by any particle may achieve in free space. So again, we have some formula regarding the frequency and the wavelength. So the speed of wavelength is the speed of the wavelength is the product of its wavelength and frequency, c equal to lambda nu. So in free space, if we have a metal medium, then we have a nomenclature v equal to lambda nu. So nu equal to c upon lambda is the basic formula regarding the speed, regarding frequency, regarding wavelength of electromagnetic wave, and it is a very important formula to calculate the speed of the electromagnetic wave in different medium. So as we know, basic some optical phenomena which is undergo by the by reflection, by diffraction, by interference. These are the some optical phenomena which is produced by the electromagnetic wave. The very important point comes in the bottom of this PPT regarding the energy transport. That the electromagnetic wave carry energy with them, and they have the momentum with them, and we have directly feel by the sensation we have received by the sunlight. How do you feel this sensation? Because they carry energy from space, and this energy transfers by the electromagnetic wave, and it is very important point regarding some basic application in electronics, in optical phenomena. So energy do carry with the electromagnetic wave in free space, and we directly feel by the sensation of sunlight on our skin. So electromagnetic wave do have the capacity to carry the momentum and the energy. The ordinary wave doesn't have the capacity to carry the energy to such a very large distance. So electromagnetic wave carry energy to a very large distance. Now move to the next PPT. So here is some wave equation. We have the wave equation for electromagnetic wave is derived from Maxwell's equation. So basically, Maxwell equation is a very detailed topic and required an independent lecture to explain what are the Max equation. But here we just explain the some basic point regarding the Maxwell equations. Like that, Maxwell equation significance the speed of electromagnetic wave, and it comes in the form of two constant. Here some mistake that we have a c equal to m naught and e naught. It is basically mu naught, not m naught. So I think you have correct it by seeing it in the some books. Under we have a wave equations. These are the basic wave equation which have a very simple mathematics. And after solving the Maxwell equation in free space, we have some basic answer regarding the solution of the Maxwell's equation comes in the form of the E equal to E naught e raised to power kx minus omega t or kz minus omega t. So hope you understand here. We are not going to explain these equation here because it covers lots of time. So Maxwell equation basically very useful to understand how the electromagnetic wave comes in the form of the solution, that E equal to E naught e raised to the power kz minus omega t or kx minus omega t. So these are the form of the solution of the Maxwell equation in electromagnetic wave. These equations shows that changing electric field, magnetic field generate the electromagnetic wave. We have discussed these points in so many times, so need to discuss here. Now move to the next PPT. So here is again the speed of electromagnetic wave in free space. I especially mention again and again speed of electromagnetic wave in free space. The reason behind that, the speed of light in metal medium may decrease according to the relation which you have seen in this PPT. In this PPT, we have a relation V equal to C divided by N. Here N is the refractive index of that particular medium. Here V is the speed of light in material medium, and you all know C is the speed of light in free space. So as greater the refractive index of the that particular medium in which we have to propagate the electromagnetic wave, then speed of light, speed of electromagnetic wave decreases accordingly. So greater we have the value of refractive index, greater in the decrease of the speed of electromagnetic wave. This relation is very important regarding your competition examination, that speed of electromagnetic wave in different media, how we connect the speed of electromagnetic wave to the refractive index of the medium in which they want to propagate. So here is the relation. By this relation, you may calculate the speed of electromagnetic wave in particular medium where they want to propagate. In free space where n is 0, so the speed of so where n is the one, sorry, in free space, so speed of light c equal to v. So in free space we have electromagnetic wave travel with speed of light, that is equal to c. In metal medium, speed may decrease according to the refractive index. This is the explanation regarding speed of electromagnetic wave in different medium. Basically, Maxwell equation, or in some better words, the most important significance of Maxwell equation, it gives the speed of electromagnetic wave in terms of constants, and these constants are mu naught and epsilon naught, and we have the value here. Mu naught is the permeability of free space, and its value is, uh, as you see here, is a constant value, and 4 pi 10 raised to the minus, and again the epsilon naught, which is the permittivity of the free space, and we have some constant value here. So Maxwell equation gives the connection between these constant and speed of light. So this all regarding the speed of light in free space or speed of light in metal medium. Now move to the further. This is some optical phenomena regarding electromagnetic wave, and the polarization of electromagnetic wave is here. First, I read the point one by one. Polarization refers to the orientation of the electric field. As I have already told you, the electric field is the parameter which is responsible for all optical property of the electromagnetic wave, and it is also called the light vector. So in many competition, the question frequently asked the light vector. It is not the magnetic field. Light vector is the electric field, which is responsible for all optical property, which is shown by the electromagnetic wave. In polarized wave, the electric field vector are confined to a specific direction. Basically, the meaning of the polarization is that when we have a particular direction in which wave vibrates, then this direction known as the direction of the polarization. Here is the types of the polarization. Basically, polarization is such a detailed topic. It itself requires a single lecture to explain the polarization. But here, I just take some small points so that you may just understand what is the polarization and what are their types. Linear polarization is one of the very important types of the polarization. In the linear polarization, the electric field oscillates along a single direction. Example, light passes through a polarizing filters. Circular polarization is a very important another types of the polarization. The electric field rotates in a circular motion as the wave propagates. Basically, in this, the motion is not linear as in the previous one. Here is the electric field rotates in a circular motion as the wave propagates, circling around the motion of the propagation of the wave. Here is example circularly polarized light. In a communication system, we have used the circularly polarized light. So this is a very important point regarding your competition examination. And now the last one is the elliptical polarization, a combination of linear and circular polarization. Here we have used the both previous types of polarization, the elliptical and polarization, and the resultants come out in the form of the elliptical polarization. So elliptical polarization is a combination or resultant of the linear and circular polarization. So here is some applications of the polarization. Polarized sunglasses we have frequently used to reduce glare by blocking horizontal polarized light as we travel on in the car. Then the car skin also use such type of glasses so that there is a very easy to drive in a night vision. LCD screens operates using polarized lights to control display visibility to give the better resolution regarding visibility point of view. Optical filters used in a photography and some scientific instruments also use these polarization application of electromagnetic wave. So I think this is all for the polarization of electromagnetic wave because it is a very wide topic and if we go some deep uh, discussion, then it may discuss the current point of the study. So here is some another optical properties of reflection and reflection of electromagnetic wave. Reflections occur when electromagnetic wave bounce back from the surface of a medium instead of passing through. And there is some law of reflection. As you all know, in optical physics, we have a law of reflection, we have a law of refraction. So there is some basics points regarding law of reflection. The angle of incidence is equal to the angle of reflection. Theta 1 is equal to theta 2. As we see in mirror reflection lights forming clear images because of this property. Refraction of electromagnetic wave. Refraction having happens when electromagnetic waves changes direction while passing from one medium to another with a different refractive index. That from one side we have a uh, some value and some other side of the medium we have a some different value. And when a wave passing from one medium to different medium, this is the process how we know the law of refraction, that is the Snell's law. And here is some relation between refractive index and of sine theta. Sine theta to the basic relation between refractive index of two media, angle of incident, angle of refraction are two angle here, which is represented by theta 1 and theta 2 respectively. Here is a critical angle, total internal reflection. These are some basics point you have to know regarding reflection and refraction. So I just want to explain a simple definition of critical angle. The angle of incident at which light is refracted along the boundary between two media. And here is a uh, some basic definition. which I want to read here, occur when the angle of incidence exceeds the critical angle, causing the wave of reflected entirely within the medium, and it is known as total internal reflection. It is a simple word TIR. It's mean total. T means total, I means internal, R stands for reflection. So don't confuse by TIR. It is a total internal reflection, which is another very important optical property of electromagnetic wave, which occurs at a specific angle of incidence. So here is again some important point regarding interference and diffraction of electromagnetic wave. So basically, interference are of two types: constructive interference and destructive interference. When a waves are in phase, their amplitude add up and producing a brighter or a more intense wave. It has a good contrast, and if the wave have a out of phase, then they have a destructive interference, resulting a dimmer or a null light in the skin or a output which we have a receive after a combination of resultant of different waves. So these are the some basic definition. These are a very broad topic and they require a very detailed manner discussion. But here we have just want to discuss some basic property of electromagnetic wave. That's why we are just reading a simple definitions so that you may understand these are not a some new kind of wave. So diffraction of electromagnetic wave also occur. So Fresnel diffraction, Fraunhofer diffraction, which we have seen, they all are the electromagnetic wave in nature. So now move further. Basically, this is a very important PPT regarding the energy transported by the electromagnetic wave in nature. So these are the special property of electromagnetic wave. No other wave are in the position which carry energy with itself in a very long distances. We feel sensation in our skin by sunlight. This is a very basic example how electromagnetic wave carry energy with them. This is the energy of the electromagnetic wave which we have feel in the form of the sun rays. So electromagnetic wave carry energy through space, and this energy may transfer to the another wave by some specific mechanism, and this property utilized in the lots of the optical phenomena, in lots of the optical properties regarding the telecommunication, regarding the waveguide which we have used in the current generation and next generation technology. So electromagnetic wave carry energy with that, and the this energy density of electromagnetic wave shown by the simple formula is capital UE equal to half epsilon naught E square. E stands for the electric field, and here we have shown the vector. The dark shade means it's a vector notation, and the lighter shade means it is a real part. So these are some basic example. The electric part is UE and the magnetic energy is capital UB, and we all know we have the both type of energy in the electromagnetic wave because it is generation by both electric and magnetic field combinedly. So in the electromagnetic wave we have the magnetic energy, we have the electrical energy, and these energy combined by the this formula. So we have the both contribution, magnetic field contribution and the electric field contribution independently. So this is how the energy is transferred by the electromagnetic wave, and it is a very special property by which they count as the very important wave for a telecommunication, for other current generation or next generation electronic capacity or some other electronic application. So these how the electromagnetic wave have the energy density in their nature. So electromagnetic wave in different media, we have discussed this point, but here just read out some important point. Electromagnetic wave travel differently depending on their medium. The speed, the attenuation, and the behavior of wave are influenced by the physical property of that particular medium in which we want to propagate a electromagnetic wave. So here a vacuum or free space, we have a speed which is called the electromagnetic wave speed of light. It is equal to 3 into 10 raised to power 8 meters a second. In free space, the wave have no attenuation or dispersion, act as an ideal medium for electromagnetic wave for the propagation. Some dielectric media or some material medium which decrease the speed of electromagnetic waves. So dielectric materials slow down electromagnetic wave speed. The speed of waves depend on the relation between refractive index n and speed of light and speed of electromagnetic wave in that particular medium. Some example of material medium is glasses, air, and water. And we know as we increase the refractive index, then there is a sharp decrease in the velocity of electromagnetic wave according to the relation which you have seen in the PPT. Some application here, some fiber optics and guide light waves are example of the applications. Now move next PPT. Again, we have a very uh, wide range of discussion. Here we have to discuss some property of electromagnetic wave in conductor or conductive medium. As I have in my starting discussion in today lecture that if electromagnetic wave propagates in conductor, then there have a phase relationship between electric field and magnetic field. They are not in the same phase. They have a phase difference of pi by 4 and pi by 2. Secondly, the speed of electromagnetic wave decreases in the conductor, and we have some important point of the propagation of electromagnetic wave in conductor. First, I read these point one by one. The electromagnetic wave has a significant attenuation, that is, the magnitude of electric field decreases as we move more and more inside the particular medium. So, electromagnetic wave induces current leading to energy dissipation as they move in the metal medium. They transfer their energy which they carry from outside. And here is a some important point. As you have seen, the name is the skin depth. So, in skin depth tells us how far the electromagnetic wave penetrates inside the medium, or in other words, when the amplitude of the electric field decrease by 1 upon E, then this is the length, this is the depth up to which electromagnetic wave propagate without deviating their amplitude. So skin depth is a parameter which tells us how much electromagnetic wave penetrate inside the metal medium without without disturbing their amplitude of the electric field, or when the electric field is reduced by 1 upon E times to their original, then this is the range of the skin depth. So skin depth is a very important parameter regarding conductor. Optical media, some transparent substances, wave undergoes reflection and refraction at the interface. This is again a dependent property of refractive index of a particular media. So some example of electromagnetic wave, infrared wave and radio wave, as we have see uh, gamma rays. So these are the bundles of wave which we have: radio wave, gamma waves, visible lights. We have these all are the electromagnetic wave which we have seen in the daily life. X-rays are a very important uh, between the electromagnetic wave, which have a very wide range of medical properties and medical significance point of view. So now the sessions comes to their ending with the start of the multiple choice question answer. First of all, we have a question. Which of the following relations proof of electromagnetic wave regarding their real electric and magnetic field amplitude, where c is the speed of light? So first of all, we have to read one by one. E equal to Bc. Here E is the electric field and B is the magnetic field and C is the speed of light. So E equal to Bc and E equal to B by C, E equal to Bc square and B equal to E by C square. These are the four options which you are available to give answer. So correct answer is E equal to Bc. So by this relation, we have a relationship between the, the electric field and the magnetic field in free space. So this is the relation which is exist between electric and magnetic field in free space. E equal to Bc and C is the speed of light. This relation may change in material medium where c is replaced by simple velocity v, and this v is again calculated by v equal to c by n, and where n is the refractive index of that particular medium. So this relation is true only for free space. But if we are talking about metal medium, then the relation is E equal to Bv, where V is the speed of light with which electromagnetic wave moves inside that particular material or medium. Hope you understand. Now again, next question. In case of electromagnetic wave, phase difference between electric and magnetic field. These question designed by me. So it may possible these questions you may know seen some other book or PPT. So keep that in mind. If we are talking about electromagnetic wave, first we have to consider the medium, whether we are talking about free space or we are talking about the material medium. So here we are in the where here we have a free space. So in free space we have a zero phase difference between electric field and magnetic field. Keep that in mind. It is a very important question regarding your completion point of view. In conductor or material medium we have a phase difference between electric and magnetic field, but in free space we have a zero phase difference. So if in an answer the question quotes clearly electromagnetic wave in free space, the answer is zero phase difference or same phase. But if electromagnetic wave in conductor medium, we have a 45-degree phase of difference between electric field and magnetic field. The under other condition that they are perpendicular to each other is intact. Both in both cases, whether in free space, whether in metal medium or conductor, electromagnetic wave are perpendicular to direction of propagation. They have a perpendicular electric field and magnetic field between each other, but the phase difference is zero in case of free space. The phase difference is pi by 4 or 45-degree in case of conductor. So keep that in mind. It is very important point. Make it clear in your mind. In case of conductor, the phase difference between electric field and magnetic field, I have clearly mentioned here conductor. So the phase difference is 45. If I mention here the free space, the answer is 0 degree. Keep that in mind. It is a very important point regarding your competition point of view. Which of the following is not true for electromagnetic wave? This is the next question. So first I read one by one the each and every options available here. Charge particle move with the speed of light in circle. As we all know, the charge particle move in circle has the accelerated motion. So this is able to produce the electromagnetic wave. Charge particle move with a constant or uniform speed in a straight line. So when we don't have the accelerated motion, when we have the uniform motion, we don't have the capacity to produce the oscillating electric magnetic field which are time dependent. So here the charged particle produce electric field which are time independent, static electric field. So B option is incorrect. And it is our also the right answer, but we have to discuss all options so that we have some more knowledge regarding production of electromagnetic wave. Charge particle moving velocity which are changing with time. So we have a oscillatory motion. So again, the motion is acceleration. The electric field, magnetic field produced by the charge particle is time dependent, oscillatory, and the electromagnetic wave may produce. Charge particle moving with uniform speed in circle. Again, this is a case of a accelerator motion. If a charge particle move with a uniform speed in a circle, then each and every point they have a direction changes and it may create the acceleration. It may has the velocity in the motion. So electromagnetic wave produced by the charge particle which is move in the circle. So the right answer which is not true, that the charge particle which is move is a uniform speed or in a rest are not in a position to produce the electric field or magnetic field which are time dependent, which are oscillatory. So the charge particle which is at rest or in uniform motion produces electric field which is static in nature, or produces uniform current. Uniformly moving charge produces a uniform currents which produce the static magnetic field which is not uh, in the position to produce the electromagnetic wave. So by ending this statement, by by ending with this statement, the electromagnetic wave is produced by the oscillating electric and magnetic field or the charge particle which move with the acceleratory motion. So today I am bind up my video lecture. Hope you enjoy this lecture. This lecture is very important regarding your CUT examination, and keep that in mind. Keep listening again and again so that you cover each and every point. Wish you all the very best of luck regarding your competition examination. Thanks. Oh, I think we have to extend some more question for you. And beside ending, we have just two questions left. So again, we have to start. Uh, which of the following statement is not true for electromagnetic wave in free space? This is very important question. We have to first read one by one every option available. E and B. E stands for electric and B stands for magnetic field. E and B are perpendicular to each other and they are in same phase. Option B, E and B are perpendicular and they have 90-degree phase difference between them. E and B are parallel to each other and they are in same phase. E and B are parallel and they have 90 phase difference between them. The correct answer is E and B are perpendicular to each other and they are in the same phase. Keep that in mind. The question has very important point, free space. So the answer is true only for free space. If the question has the conductor, which of the following statement is true for electromagnetic wave in conductive medium or in conductor? The answer is again 45-degree out of phase. So keep that in mind. These are the very important small key points which you have to in your mind when you are solving the questions regarding electromagnetic wave. Which of the which of the basically options are questions is the same. The answer is some different. Basically, we have a electromagnetic wave are transverse in nature. Electromagnetic are longitudinal in nature. They travel with the speed of light. The question is that which of the following statement is true for electromagnetic wave in free space? Again, we have an electromagnetic wave in free space. So electromagnetic wave and transverse in nature and travel with the speed of light. But if we have make some changes in question like that, which of the statement is true for electromagnetic wave in conducting medium? That electromagnetic wave are transverse in nature inside the conductor, but they don't travel with the speed of light. They travel with speed which is less than the speed of light, and we have to find by speed of light by the relation v equal to T by N, where N is the refractive index of that particular conductive medium. So hope you understand how do we read the questions and how do we solve the question according to the keywords, whether they asking speed of light, whether they are asking their relationship between electric field and magnetic field in free space or in conductors. So hope you enjoy this video lecture. Now it's time to bind up. Thank you. Wish you all very best of luck for examination.